Israel made an unprecedented feat when employing a laser weapon, called Iron Beam, to defend against drone attacks, quickly transforming a laboratory project into a functional weapon. This advance marks one of the greatest technological innovations in the military field of recent years, showing the Israeli capacity to react extremely agility to real and constant threats that challenge their national security. Iron Beam is created to offer precise, economical, and fast air defense, especially against short-range threats such as drones, rockets, and handcrafted missiles. The emergence of this technology was no coincidence. It was born from the need to find an effective and affordable response to the growth of hostile group attacks, such as Hezbollah and Hamas, which often use these low-cost weapons and difficult interception. Iron Beam's conception was not just an ambitious project. It was driven by the urgency of protecting Israeli territory and its civilian populations. For years, the country has lived with the daily threat of rockets fired from neighboring territories, forcing the population to live under the constant risk of anti-aircraft sirens and shelters. The conventional response to this threat was the famous Iron Dome system, which revolutionized the Israeli defense, but also presented a challenge: the high cost of each interception, which could reach tens of thousands of dollars per missile released. In this context, the development of a directed energy-based weapon emerged as a solution not only more efficient but also much cheaper. And it was precisely this view that led to the creation of Iron Beam, with the clear goal of providing immediate, low-cost, and highly effective defense. The system was conceived by the Israeli defense industries, with leadership from the company Rafael Advanced Defense Systems, which already has long experience in the development of anti-missile systems. During Operation Iron Swords in 2023, Israel faced one of the biggest coordinated attacks of drones and rockets conducted by Hezbollah from southern Lebanon. This episode became a milestone not only for the volume of the attack, but mainly by the way Israel reacted, placing in operation for the first time Iron Beam in a real combat scenario. The urgency of the moment has made the system implementation impressively accelerated. Only 18 months have separated the conception in the laboratory of effective use on the battlefield. This unprecedented implementation speed demonstrates not only Israel's technological competence, but also its ability to mobilize in critical situations. Amid conflict, engineers, many of them summoned from the reserve, worked intensely to adjust and calibrate the system in real time, ensuring that it functioned in a practical and efficient manner against concrete and immediate threats. Iron Beam's operation was considered a resounding success. The system was able to intercept dozens of short-range drones and rockets, which would otherwise pose a considerable risk to the population and infrastructures of northern Israel. The images released by the Israeli Ministry of Defense showed the power of the system. Laser beams, invisible to the naked eye or visible as bright traces, quickly reached air targets, destroying them before they could do any damage. This feat was more than a demonstration of strength. It was proof that the new generation of air defenses need not necessarily depend on expensive missiles or limited ammunition stocks. With Iron Beam, Israel has shown that it is possible to neutralize threats using a system that only depends on electricity, working almost unlimitedly as long as there is available energy. Iron Beam's functioning is based on an advanced concept of directed energy weapon, using multiple laser beams to destroy air targets. These beams are triggered with millimeter accuracy, converging on the target until concentrated energy is sufficient to destroy it. The main advantage of this system in relation to traditional air defense methods is in the cost of shooting. While an Iron Dome missile can cost between $40,000 and $100,000, each Iron Beam shot represents only a tiny fraction of this value. In addition to cost, there is another important differential: the absence of physical ammunition. This means that, unlike missile-based systems, which are limited by the amount of projectiles available, Iron Beam can continue to operate indefinitely as long as there is a continuous supply of electricity. This feature ensures a virtually uninterrupted response capacity, essential for prolonged or intense attack scenarios. However, like every new technology, the system is not free of challenges. One of the main technical obstacles faced during the development and implementation of Iron Beam is related to air density, which may interfere with the effectiveness of laser beams, especially when targets are over great distances or under adverse weather conditions such as fog, rain, or sandstorms. To mitigate this problem, Israeli engineers opted for an innovative design. Iron Beam uses hundreds of small laser beams, all directed simultaneously to the same point on the target. This approach significantly reduces energy dispersal along the way, increasing the accuracy and power of the shooting. When the system detects that a beam has hit the target, other beams are automatically redirected to reinforce the attack until complete destruction is guaranteed. This method makes Iron Beam especially effective against relatively slow and predictable targets such as drones and short-range rockets, which have easier trajectories to be accompanied and neutralized. However, there are still important limitations, especially when it comes to facing mass attacks or targets that move at very high speeds. These limitations do not prevent Iron Beam from being considered a monumental advance in Israeli air defense. On the contrary, they indicate that despite restrictions, the system already plays a key role in the country's defensive architecture. And it is precisely about the strategic role and how Iron Beam integrates with Israel's complex air defense system which we will speak. Iron Beam is part of Israel's air defense as another strategic layer within a system that is already considered one of the most sophisticated and complete in the world. Israel has been developing a defense architecture based on the concept of multiple layers, where each system is responsible for neutralizing specific types of threats, according to their speed, reach, and technical characteristics. This complex currently includes Iron Dome, designed to intercept short-range rockets and obuses, David Sling, which covers medium-range threats, and the Arrow system, which deals with long-range ballistic missiles and even threats outside the Earth's atmosphere. With the introduction of Iron Beam, Israel adds an unprecedented and complementary layer, capable of acting especially against very tight-range threats, such as drone swarms and makeshift rockets, which are fired a few kilometers from the border and reach their targets in a matter of seconds. This integration between systems is essential to ensure that no threat is unanswered. Iron Beam acts as the first line of defense, rapidly intercepting the simplest and most numerous attacks, while missile-based systems are reserved for more complex or larger threats. Thus, Israel optimizes its resources and significantly reduces defense operating costs, as Iron Beam's shots are extremely cheap compared to the high cost of an interceptor missile. In addition, laser use eliminates one of the most worrying problems associated with conventional systems: splinters. When a missile intercepts an enemy rocket, the explosion generates fragments that may fall over inhabited areas, endangering the life of civilians and causing collateral damage. With Iron Beam, this concern practically disappears, as the target destruction occurs cleanly through burning or disintegration caused by the energy concentration. Another important aspect is the system response speed. While a traditional missile takes a few seconds or even minutes to be prepared, launched, and hit the target, Iron Beam fires instantly as soon as the threat is detected. This speed is fundamental in scenarios where drones or rockets are released in large quantities, with the intention of saturating defenses and causing as much damage as possible before they are intercepted. In Operation Iron Swords, Iron Beam's performance clearly demonstrated this differential. According to official reports, in various situations, the system was able to neutralize multiple targets simultaneously, something that would be much more difficult and expensive with systems based exclusively on missiles. Videos released show how, in a matter of seconds, the laser beam hits the target and destroys it, even before it approaches inhabited areas. However, despite these advantages, the system still faces important technical limitations. The main one is precisely the difficulty of intercepting extremely fast or small targets that move erratically, such as certain types of cruise missiles or suicide drones. In addition, laser performance can be affected by unfavorable environmental conditions such as heavy rainfall, dust, or fog that disperses or absorb part of the bundle energy before it reaches the target. Even so, Iron Beam's strategic potential is undeniable. Its introduction to the Israeli arsenal marks a radical change in the cost-effectiveness of air defense. For the first time, the defense became cheaper than the attack. Traditionally, defensive systems are more expensive than the weapons used by aggressors, but Iron Beam has reversed this logic. While a handmade drone or home-made rocket can cost a few $100s, its neutralization by Iron Beam can cost only cents. This new paradigm represents a significant advantage for Israel, especially considering the financial and logistics challenges that arise in prolonged conflicts. The possibility of intercept thousands of threats without rapidly exhausting financial resources or missile stock provides unmatched strategic security. In addition to the current context, Israel is already planning to broaden Iron Beam's abilities to new scenarios and operating environments. One of the most promising projects is the adaptation of the system for naval versions, capable of protecting military and civilian vessels against air threats. The Israeli Navy has already shown interest in equipping patrols and corvettes with Iron Beam, especially for operations in the Mediterranean Sea, where there is a risk of missile attacks and drones from hostile coastal zones. Another development front includes the creation of mobile and portable versions that can be easily transported and installed on land vehicles or even temporary combat positions. This type of application would be extremely useful in military operations in remote areas or vulnerable borders, where the speed of implementation and operational flexibility are essential. These advances indicate that Iron Beam is far from just a static and limited solution. On the contrary, it is the foreshadowing of a new generation of defensive systems that combine mobility, accuracy, economy, and sustainability. The use of electricity as a primary source eliminates the need to maintain voluminous ammunition stocks and facilitates operation logistics, significantly reducing costs and risks associated with explosive transport and storage. In fact, many military security and technology experts already point to Iron Beam as a concrete example of how modern war is being transformed by directed energy-based weapons. While in the past laser systems development was seen as a distant promise, restricted to theoretical laboratories and experiments, Israeli experience has shown that these weapons are already a functional and highly effective reality. Israel made an unprecedented feat when employing a laser weapon called Iron Beam to defend against drone attacks, quickly transforming a laboratory project into a functional weapon. The success of this implementation has consolidated not only a technological advance, but a true turn on the concept of modern air defense. Iron Beam is created to offer precise, economical, and fast air defense, especially against short-range threats such as drones and rockets. Its operation principle is relatively simple. It uses multiple highly concentrated laser beams that converge on the target, heating its structure to destruction. This process occurs in second fractions, making the system extremely effective and agile. During Operation Iron Swords in 2023, Israel faced one of the biggest coordinated attacks with registered drones and rockets, conducted mainly by the Hezbollah group. The magnitude and intensity of these attacks have put in check the traditional missile-based defenses, which, although effective, have a high cost and a slower response rate. It was in this context that Iron Beam's implementation was accelerated, taking only 18 months from conception to effective use in combat, a record time when it comes to innovative weapons systems. The system was successfully used to intercept dozens of drones and rockets that threatened Israeli territory. Images released by Israel's defense forces show the laser reaching and quickly destroying the targets, often even before they crossed the border or dangerous to inhabited areas. These videos viralized, drawing the attention of military analysts and technology experts around the world. Iron Beam is a directed energy weapon that shoots multiple laser beams in sequence or simultaneously, depending on the type and amount of threats detected. Each shot costs only a fraction of the value of a traditional missile, such as those used by Iron Dome, a system that has already been consolidated as an Israeli defense icon. While an interceptor missile can cost tens of thousands of dollars, Iron Beam's shooting costs only a few cents, considering that the only need is the supply of stable electricity. This ability to trigger indefinitely as long as energy supplies gives the system an undeniable tactical advantage in asymmetrical war scenarios, where groups like Hezbollah or Hamas use saturation tactics, firing large volumes of rockets and makeshift drones. Iron Beam, with its agility and low cost, breaks this model, preventing mass attacks from rapidly depleting Israel's defenses. The system uses hundreds of small, concentrated beams, which combine to destroy the targets. It is especially effective against drones, slow and projectile rockets, which usually follow predictable trajectories. However, it still has limitations against extremely rapid or sophisticated targets, such as cruise missiles, which can maneuver to escape the defenses. Despite these limitations, Iron Beam perfectly complements Israel's defensive architecture. It is part of Iron Dome, Arrow, and David Sling, forming a layered defense system that protects the country against a wide variety of threats, from makeshift rockets to intercontinental ballistic missiles. This integration ensures that, regardless of the type of attack, Israel has a proportional and efficient response. Iron Beam's introduction also brings additional benefits, such as reducing the dependence on expensive systems and decreasing the risks associated with the splinters generated by traditional missiles. By destroying targets through concentrated heat, the system prevents fragments from falling over urban areas, increasing the safety of the civilian population. Iron Beam's success has already boosted plans to expand its application in new scenarios. Naval versions, designed to protect military and commercial vessels against air and sea attacks. In addition, portable and more compact models are being tested for land operations, allowing mobile infantry or armored units to be equipped with laser defenses, increasing protection in conflict zones. This weapon undoubtedly represents a paradigm change in Israeli defense and modern war as a whole. For the first time, the defensive cost is lower than the offensive cost, breaking the historical logic that has always favored the aggressor in financial terms. Now each rocket or drone launched against Israel is a greater damage to those who attack than for those who defend, discouraging saturation-based offensive and forcing hostile groups to rethink their tactics. The international impact is also significant. Several countries have already shown interest in similar systems, observing Iron Beam's performance as an indication that power weapons finally left the experimental to operational field. United States, Germany, South Korea, and even Japan are developing their own laser weapons programs, inspired by the efficacy demonstrated by the Israeli system. In addition, Iron Beam's success drives important debates about the future of war. The advance of directed energy technologies may represent the beginning of a new era, where the determining factor will no longer be the amount of ammunition anymore, but the ability to generate and sustain enough electricity to maintain indefinite operational defensive systems. In short, Iron Beam is not just a new weapon in the Israeli arsenal. He is the symbol of a radical change in the way nations think about the defense of their territories. More than protecting Israel, the system inaugurates a new security age based on efficiency, accuracy, and, above all, the economic rationality of military operations. This is undoubtedly a milestone in the history of military technology, and perhaps only the first chapter of a revolution that is still beginning.